Hello guys, and welcome back to another video of Stats Tutoring, Easy Stats with Danny D. And I hope you guys are good. And I just want to thank you guys for 100+ subscribers. I've seen the analytics; they look really good. Thank you guys so much for the support. And if you're new to the channel, please subscribe and hit the notification bell so that you'll be notified whenever I drop another video. Alright, so in today's video we'll be going through factor analysis, which is study unit 2. Um, so these are the study outcomes, all you need to know. Like always, we'll be going through each and everything that you need to know. So we have the introduction, and then we have to know factor extraction. We have to know the variance explained by the factors. We need to know um, percentage variance explained by factors, calculate and interpret communalities. You need to know how to determine if the factor loadings are significant. We also need to decide if rotation was successful or not. Let me just, yeah. Okay, so this is what we need to know, and we're going to be going through each at a time. But before all that, we need to start with the introduction, obviously. What is factor analysis? All right. So if we can just track back a little bit, in study unit 1, we learned that we can determine the value of the dependent variable, which is the y variable, given the independent variable being the x variable. And we also learned in multiple regression that we can have more than one independent variable, the x variable. Like you can have x1, x2, x3, and x4. So basically that tells you that we can have more than 3, more than 5, more than 10 uh, independent variables. So basically, if we have so many variables, we have a lot of information, we have a lot of variables that it is difficult to make decisions based on that. It is difficult to determine the relationship between the those variables against each other. So now factor analysis, what it does is it reduces the number of variables into a smaller number of factors, but without reducing the information. Basically, we are retaining maximum information. We want a lot of information, but with a fewer number of factors. That is basically what factor analysis is. Let me actually give you an example here. All right, so we have an example here, which let's say we want to determine the personality of a person. We want to determine the personality of a person, and then we have 6 variables. Those variables like are in the form of questions. We go and ask students uh, about their social life and stuff like that. So we go and ask them, do you enjoy social gatherings? Do you like to make new friends? Do you feel nervous in new situations? Do you often feel sad? Are you talkative? Or do you prefer being alone? So this is more like a yes or no questionnaire. And then from there we design what we call a factor metric, correlation matrix. So correlation matrix looks something like that. Correlation matrix is basically the relationship between the variables against each other. So the relationship between variable 1 against variable 1 obviously is going to be 1. So against variable 2 and variable 2 is going to be 1, as you can see. So we are uh, we're checking the relationship between these variables against other variables. Like for example, if you look at variable 1 and variable 2, the relationship is 0.75, meaning it's a strong relationship between these two. Look at variable 1 against variable 5. It's also a positive and also a strong uh, relationship between variable 1 and variable 5. Let's look at variable 2 and variable 5, 0.65, also is strong. So looking at this, we can actually notice that variable 1, variable 2, and variable 5, they are strongly correlated. They have a strong relationship amongst each other. And when you look at the questions for variable 1, or the description for variable 1, variable 2, and variable 5, it says I enjoy social gatherings. This one says I like to make new friends, and this one says I am talkative. All right, and then let's go and look at the remaining variables, variable 3, variable 4, and variable 6. Variable 3 versus variable 4, 0.70. You see the strong relationship. Variable 3 against variable 6, 0.60, which is also a stronger or a positive relationship. And then variable 4 against variable 6 over here, 0.55, it's also a positive relationship. So you can see that the remaining variables, variable 3, I feel nervous in new situations, I often feel sad, and I prefer being alone, is another 3 variables that have a positive relationship or a strong correlation amongst each other. And then when you look at the questions, like I said, the description, I feel nervous in new situations, I often feel sad, and I prefer being alone. So we can actually name the first 3 variables that we saw the correlation. Variable 1, I enjoy social gatherings. Variable 2, I like to make new friends. And variable 5, I am talkative. We can say variable 1, variable 2, and variable 5, we name it into one factor, and we call it extrovert, because a person who enjoys social gatherings, who like to make new friends, and who's talkative is an extrovert, obviously. So that is the personality of that person. We determine the personality based on those variables, and we grouped it into one factor. And then we look at the remaining ones. I feel nervous in new situations. I often feel sad, and I prefer being alone. People who prefer being alone, who are nervous in new situations, we call them the introverts. So we can now move from 6 variables to only 2 factors. Factors being introvert and extrovert. You see, so that is all about factor analysis. We reduced the number of variables into a few factors, but we still have a lot of information. We know that this person is an introvert, or this person is an extrovert. So it's just those two. But we started with 6 variables. So that is all about factor analysis. So now that is the introduction, and that is what factor analysis is all about. Now remember, this was just a small example. So you might find that you have like a lot of variables, like 15 variables, 20 variables, or 10 variables. So with our variables, there were only 6, so that is why we had only 2 factors. So in most cases, you'll find that the examples that they give you, or the test that they give you, it's more than 10 variables, and therefore the factors that were they group those variables into are more than 2, maybe 3 factors, 4 or 5 factors. 5 factors. So that is where factor extraction is going to come in, like where you're going to determine how many factors should be extracted, basically meaning that how many factors you should keep, and then the rest of the factors you shouldn't keep based on their importance, basically. So to do that, we're going to look at this example. But before we do factor extraction, I want us to do to calculate the variance explained by factors and the percentage variance explained by factors. So the reason for that is that they will give you a question like this. For example, they'll give you a factor and they'll give you the variance explained. Then they'll ask you to calculate the missing value in the variance explained. So basically being this one. So there are 2 ways to calculate the variance explained. If they gave it to you like this, it's simply the number of the variance explained, the total variance explained is equals to the number of factors. In this case, there are 6 factors. So meaning that when you add these numbers, all of them, including this, they should give you 6. So calculating the value of A will simply be 6 minus everything that is here, like I did here. It's going to be 6 minus 3.26 minus 1.25 minus 0.72 minus 0.46 minus 0.24 minus 0.24, and that is how you get the value of A over there. That is how you get the value of A over there. And then sometimes they will not give it to you like this. They will give it to you like this, whereby we have the variables, and then we have the variance explained. They give you the factors, and they give you these numbers in between the numbers that we call them the factor loadings. We'll get into that in a later stage, actually, whereby we do something like significant factor loadings and stuff like that. But all you have to know is that these numbers in between are called the factor loadings. And then they'll come and ask you a question like, calculate the missing value, which is C, and the value C is actually the variance explained by factor 2. Understand? The variance explained by factor 2. Even here, they'll say to you, calculate the variance explained by factor 6, which is denoted by letter A. So here is going to be calculate the variance explained by factor 2, denoted by letter C. So when you're given like this, how you're going to calculate it is you're going to take all these factor loadings, you put in brackets, you square them, and you add them. So basically, the value of C is going to be equals to you put in brackets. Let me just do this. How many variables do you have? 1, 2, 3, 4, 5, 6, 7, 8. Okay, I'm gonna do this and then I'm gonna square it, then say plus, put in bracket, write another bracket, square, plus, another bracket, square, plus, another bracket, square, plus, another bracket, square. 1, 2, 3, 4, 5. Let me write 3 more. Plus, I'm gonna square this, I'm gonna square this, I'm gonna square this. Okay, now I'm gonna write these numbers in between. I'm gonna use this because it's simpler to write it like that. Okay, so I'm gonna say minus 0.202, just reduce it a bit. So it's gonna be minus 0.202 squared, and then minus 0.382, no, not minus, positive 0.382, also in brackets, and then let me rather do this actually. The next one is 0.232, 0.244, followed by minus 0.310, and then here we're going to have minus 0.140, 0.651, minus 0.458. All right, so these are our values. These are our values. So that is how we calculate the variance explained by letter C over here. Variance explained by this letter C over here. So after you wrote these numbers, what you're going to do is you're going to go to your calculator, and then you're going to press those numbers. Minus 0.202 in brackets squared plus 0.382 in brackets squared plus 0.232 close bracket squared, just like that, all of them, plus 0.244 squared plus minus 0.310 squared plus minus 0.140 squared plus 0.651 squared plus minus 0.458 squared. And the answer is 1.049. 1.049. So that would be the answer. The answer would be C equals 1.049. So that is the answer for the variance explained. This one, the variance explained. So that is how you calculate variance explained when you're given the factor loadings. When you're given the factor loadings, and when you're given it like this, you just say 6 minus everything. Sometimes it's not going to be here, the A. It's going to be maybe here. So it's just going to be the same. It means they'll give you this value in that case. So it's going to be 6 minus this minus this. If this is not there, minus this, and minus the value you'd be having here in that case. But then one thing you must know is that the factors are in order of importance, meaning that they range from the highest to the smallest. As you can see, 3.26 is bigger than 1.25, is bigger than 0.72, is bigger than 0.46, is bigger than 0.24. So meaning that the value of A should be the smallest, and as you see, 0.07 is smaller than 0.24, and all of them. And then here as well, as you look at the one that we calculated here was 1.049, and this is 3.432. So factor 1 is bigger than variance explained by factor 1 is bigger than variance explained by factor 2. So that is how you calculate the variance explained. Always remember to put these numbers in brackets, you square them, then you add them as you go down. So that is how you calculate the variance explained. So that is that part over there, calculating the variance explained. Calculating the variance explained. All right, so now percentage, calculate the percentage variance explained by factors. So this part, the reason why I actually did this before going here is this built from this. So percentage variance explained is basically variance explained. If they gave it to you like this, is variance explained divided by the number of factors and then multiplying by 100. So for example, let's say they say calculate the variance percentage variance explained by factor 1. So in that case, it means they want you to take this factor 1, the variance explained is 3.02, so you're going to say 3.26 divided by 100, and then you want to say let me write here, divide by 6 multiplied by 100, sorry, divide by 6 because the number of factors are 6, so it's going to be divide by 6, divide by 6. So let me just do it like this. Yeah, so it's 3.26 divided by 6 multiplied by 100, and the value for that is going to be equal to, you just get the calculator, 3.26 divided by 6 and multiply by 100. The answer is going to be equal to 54 point 54.33 54.33. So 54.33 is the percentage of variance explained by factor 1. So if they said, let's say factor 1 and factor 2, then you just add 3.26 plus 1.25, you divide by the number of factors, and then you multiply by 100, just like that. So now, when you're given factor loadings like this, and then they say to you, calculate the variance explained by factor 1. So basically this is the variance explained by factor 1, 3.432. So in this case, you take the variance explained. Let's say this is the variance explained, 3.423. You divide by the number of variables. So in this case, it's going to be 1, 2, 3, 4, 5, 6, 7, 8. So you're going to divide by 8. You're going to divide by 8, then you multiply by 100. You multiply by 100. And then for you to get that value, I'm going to go to the calculator. Divide by 8. That is 432. The answer would be 42.9. So let me just erase this part here. It's 432, and the answer is equals to 42.9. 42.9. So that is how you calculate the percentage of variance explained by a factor. Sometimes they will say calculate the variance explained by the extracted factors. So if these two are the extracted factors, then like I said here, when they say factor 1 and factor 2, you're just going to add this factor and this factor, the one we got here, and then you divide by the number of variables and multiply by 100. That is how you calculate the percentage variance explained, right? Okay, cool. So now that is how you calculate the percentage variance explained by a factor, right? So now this is the next part that I need. Okay, so now factor extraction. How many factors should be extracted? How many factors are important so that we can use them and maybe leave out the rest? For example, here we have 6 factors and we have the variance explained by those factors. So now we want to know that which factors are more important than the others and which factors should we extract. So that is where factor extraction comes in, right? Okay, so I use the computer program to actually draw the what we call the Scree plot. So we're going to be using what we call a Scree plot to determine how many factors should be extracted, and we'll also be using what we call Kaiser's criterion. So let us start with the Scree plot. So Scree plot is something that looks like this. A Scree plot is something that looks like this, and it has the variance explained on this side. As a variance explained on this side, and then you have a factor number on this side. So as you can see here, we have 6 factors, 1, 2, 3, 4, 5, 6, and as we do here, 1, 2, 3, 4, 5, 6 factors. So the first factor was 3.26. As you can see, 3.0, so 3.2 will be above that, so that is the point there. So the second factor, 1.25, this is 1, this is 1.5, so 1.25 will be in the middle, and so on and so on. So they might ask you actually to draw the Scree plot, so you should know how to draw a Scree plot. So when you draw it, make sure that everything is according to scale, and then you name your axis. You also name you also write down the heading or the caption for your Scree plot. So it's a Scree plot which explains the variance explained by each factor, the 6 factors here. So now, according to the Scree plot, we only extract factors from where the graph starts to flatten. We only extract factors from where the graph starts to flatten. So if you can look at this graph here, it's very steep from here up to this point, and then from this point it actually starts to bend, but I would say that it actually starts to flatten from this point over here. It actually starts to flatten from this point over here. So now when it comes to Scree plot, you might find that there are 2 possible answers to the question. Like they ask you how many factors should be extracted here. So according to the Scree plot, as we look at it, the graph actually starts to bend here, but it starts to flatten over here. So we can say that according to the Scree plot, we must extract factors from where the graph starts to flatten. So we can say 1, 2, 3 factors. So we can say we extract 3 factors from this. However, even though you say we extract 2 factors, because some people actually use this together with the cases criterion, which I'm going to explain now. So now we can say that 1, 2 factors should be extracted, or you can say 1, 2, 3 factors should be extracted, because this is where the graph starts to flatten. If they say motivate, you say this is where the graph starts to flatten. So your graph is always going to be like this. It's going to decrease from the left to the right, right? Okay, and then according to what we call cases criterion says that the average of the variance explained against the factors is always equals to 1. And that actually makes sense, because remember I said that this is equals to the number of factors. How many factors we have is 6. What is the total of this is 6. 6 divided by 6 is 1. So meaning that the average is going to be equals to 1 all the time. So now we must extract factors that have a variance explained more than 1. So how many factors here have a variance explained more than 1? Is this one and this one. So only 2 factors should be extracted according to Cases criterion, factor 1 and factor 2. So now that's what I say, that sometimes people use both Cases criterion and the Scree plot to extract factors. So meaning that if we were to add the Cases criterion as well here, we'll draw a line somewhere here. And if we draw that line over here, we see that only 2 factors are above that line. Only 2 factors are above that line. So meaning that 2 factors should be extracted if you're using both of them. And then if you're only using the Scree plot, if you say 2 or you say 3, they will be lenient and give you a mark for that. So that is how we extract factors. So according to Cases criterion, you look at factors that are above 1, and then according to the Scree plot, you look at where the graph starts to flatten. That is how you answer the question of factor extraction. So that is as easy as I just explained. Right, that is how you extract the factors. Okay, and then the next thing, how to calculate and interpret communalities, right? Okay, so communalities, they'll ask you based on factor loadings like this. So they won't ask you communality here, they'll only ask you communality on the table that looks like this. So just like with variance explained, when we're putting the numbers in brackets and squaring them, then adding them going down, with communality we do the same thing but going across. So basically what this means is variance explained is for a factor and communality is for a variable. So when it comes to communality, they'll ask you calculate the communality for a certain variable, and they'll also ask you to interpret it, right? Okay, so calculating the communality, what you're going to do is you're going to add the numbers. So let me start with this one. I'm going to get to this value of a in a short period of time. So let's say they ask you calculate the communality associated with the variable business. So this is the variable business. So now the communality for that is going to be 0. It's going to be 0.71171. Sorry, mouse is shifting. 711. You put it in brackets and then you square it, and then you're going to say plus, you open bracket, 0.382. 0.382. So you also square it, and then the communality for that is going to be equals to, you go to the calculator, you say 0.711 squared plus 0.382 squared, that is equals to 0.651. As you can see, they got it here, 0.651. That's how they got that. So let's say they wanted you to calculate the one for psychology. Is it psychology? Yeah, for the one for psychology. So the one for psychology, this is equal to 0.651. So that is how they got that 0.651 there. Okay, if they ask for the one for psychology, then it would be the value of b here would be 0 minus 0.657 squared plus 0.6% squared by 0.232 squared. Therefore, the value of b will be equal to, go to the calculator, and then you just write your values there. Minus 0.657 squared plus 0.232 squared. That's equal to 0. The value of b is 0. Is it 485? 485, yeah. 0.485. That is how you calculate the communality. So now, if they say interpret communality, you interpret it in terms of percentage. So the number that you get here, you multiply it by 100. So at 0.485, you say multiply by 100. You're going to say multiply by 100. And then from there, the number that you're going to get is going to be equals to 48.5. 48.5. Excuse me. It's going to be 48.5. So how do you interpret it? 48.5% of variation of psychology. This is psychology, ne? Of psychology. Of psychology is explained by the extracted factors. It's explained by the extracted factors. That is how you interpret it. 48.5% of variation of psychology is explained by the extracted factors. So the same for all the other variables. That is how you actually interpret it. You just want to change the name of the variable. Actually, that's basically what you're going to do. So if it's for example, it's for Akhle, you're just going to say 74.6% of variation of Akhle is explained by the extracted factors. That is how you explain, you calculate communality and interpret it. Right. Yeah, remember factor 2, like I said, factor analysis study 2 is not a lot, so this video is not going to be the longest. Okay, determine if the factor loadings are significant. All right, so we're going to go back to our table. So now a significant factor loading is a factor loading that explains more than 10% of the variance explained. That explains more than 10% of the variance explained. And we should include both the negative and the positive side. So you'll see in your slides it's given by the square root of 0.1, which is 10%, 0.1, 0.1, and also minus the square root of 0.1. And if we calculate this, you get 0. Let me actually start with the minus 1. Let me say plus here, the positive 1, and then here the minus 1. Okay, if you take this on your calculator and calculate this minus the square root of 0.1, you get 0.316. So 0.316 is our guideline, minus 0.31 minus 0.316 and positive 0.316. So now any number that is less than this or is bigger than this is considered significant, and any number that is in between, it is not significant. Any number that is in between, it's not significant. A number that is more than this or more than this, I mean less than this or more than this, is significant. So sometimes when it comes to negative numbers, students tend to make mistake. Like you'd find someone saying that 0.6 is bigger than 0.4, minus 0.6 is bigger than minus 0.3, of which that is not the case. Minus 0.3 is bigger than minus 0.6. So when it comes to this, I tell my students that um, maybe sometimes you should just forget the negative one. You look at the number. If it's a negative, let's say for example minus 0.657, we know that this is smaller than this. So meaning that it's not here, it's that side. So remember, minus 0.3, minus 0.4, minus 0.5 go to the left, and then on the right is going to be positive numbers. All right, so let me actually not confuse you any further, but this is our guideline as to which factor loadings are significant. So factor loadings in between these two numbers are not significant. They are not significant. And then factor loadings that are going that side, they are significant, and the ones that are going that side are also significant, right? Actually, let me erase this here so that I can actually explain this better, right? So that is all we need to know about the significance. So meaning that from this you can just go and see which factor loadings are going to be significant, which ones are not going to be significant. So for example, minus 0.202 is somewhere here in between, so it is not significant. And then 0.711 is somewhere there, it's significant. 0.643, 0.643, 0.626, they are somewhere there, significant. You get the picture, right? So that is all about the significance and the not significance of the factor loadings, right? And yeah, before we continue, I want us to calculate the value of a, because we're gonna need it somewhere. So now the value of a can be calculated in two ways, but always look for the simpler way. By this I mean that, remember, when we calculated the value of c, we put everything like here in brackets, this, we put them all in brackets, we square them like it is here, and then we calculated the value of c. Ne? So if you were to calculate the value of a, ne, you went to say a in bracket squared plus this in bracket squared plus this in bracket squared all the way up to this, and say is equals to 3.432. Then you'll need to know what you call basic algebra to just calculate the value of a. However, if you have a lot of numbers, sometimes you can make mistakes, so just look for a simpler way. And by a simpler way I mean, remember, communality is just equals to this squared in bracket squared plus this in bracket squared is equals to this, because you have the value of the communality. So calculating the value of a in simple way would just be a in brackets, you square it, a in bracket squared is equals to, I mean plus minus 0.202 minus 0.202 in brackets squared is equals to 0.596, 0.596, right? 0.596. Okay, and then after this you have the value of a squared, right? So you want a squared on one side, so meaning that you're going to take this onto the other side. So a squared will be equals to 0.596 0.596, and then this comes to the other side, then it becomes a minus. So you can literally just go to the calculator and get the value of this. Just going to say minus 0.202 squared, and in brackets squared, at 0.041, because it's 8, it adds 1 here, so it's going to be 0.041, 0.041. And then now to get the final answer, you're going to say a is equal to the square root of that. It will be equal to the square root of that. So the square root of that is going to be the square root of, we can now say, okay, 0.596 minus 0.041 equals minus 0.041 equals 0.555. 0.555. Writing with the mouse is not easy. 0.555. Right. Okay, now that we have this, then we say the value of a is equal to, remember, plus or minus, because you must say plus or minus, because the factor loading can be a negative, but if you put it in brackets and square it, it will give you a positive number. So you must say plus or minus that number. So now 0.555, you take the square root of that, square root of 0.555, the answer is 0.745. So you're going to say that is plus or minus 0.745. That is the value of a over here. The value of a over here is going to be 0. Plus or minus plus or minus 0.745. That is the value of a. Let me just reduce it. Right, that is the value of a, plus or minus 0.745. So now that we have that, we can also determine if it is significant or it is not significant. And this actually takes us to the next step, which is deciding if rotation was successful or not. All right, so please go and read about rotation. They will not ask you to do rotation because we do it using the calculator, but they will rotate the factor matrix. So rotation is basically to help us determine if a variable is for, we should put a variable in factor 1 or in factor 2. Like for example, economics, should it be factor 1 or should it be factor 2? And we can also use the significance of the factor loadings to determine that. So like for example, we see that economics is significant in factor 1 because minus 0.745 would be significant, or positive 0.745 would be significant. So in factor 1, economics is significant. In factor 2, it is not significant. So we can say economics should be associated with factor 1. And we do the same for all the other variables. So now, rotation is actually to determine where we should put those variables, because sometimes you find that there is a variable with more than one significant factor loading. So in that case, you don't know in which factor you should classify that variable, right? So now that is what we call a complex variable. So now a complex variable is a variable that has more than one significant factor loading. So basically, if a variable has two or more factor loadings, significant factor loadings, you don't know whether to put it in factor 1 or in factor 2. So let's say this is factor loadings after rotation. This factor loadings after rotation, and then they ask you. So there are four types of uh, uh, rotations. There's the Varimax rotation, there's the principal component rotation. I forgot the other two, but yeah, they are there in the slides. They won't ask you to do the rotation, but you should know that those are parts of rotation, because they can ask you a question like that actually when it comes to the theory that which one of the following is not a an example of rotation, or they can ask you maybe in the test that name the four types of rotation. So you should know them. They are there in your slides, and remember, you are allowed to bring your textbook and your slides, so you should be fine. Right. So now they will ask you that after rotation, was this rotation successful? So for that, if you given this, if you are given this uh, table and they ask you, was the rotation successful, you're going to ask yourself, are they complex variables? Are they a complex variable? So a complex variable is a variable that has more than one significant factor loading. Let's look at economics, for example. Economics has one significant factor loading and the other is not significant. So meaning that economics is not complex. And then let's look at business, 0.711, that is significant. And then let's look at the other one, 0.382. 0.382 is more than 0.316. So that is also significant. So there are two variables that are significant. Therefore, we would say that rotation was not successful in this case. If this is the table that they give to you and say this was after rotation, then you want to say no, the rotation was not successful because there are still variables that are complex, or there are still variables with more than one significant factor loading. Let's look at the other ones like uh, AGLE, for example, actually 0.5 is significant and 0.651 is also significant because it's more than 0. They are both more than 0.316. In that case, would say that AGLE is also a complex variable. The same with marketing as well. But then if we look at value variables like psychology, this is significant, this is not significant, this is significant, this is not significant. So those are the variables that are not complex. Communications, this is significant and this is not significant. Here, this is significant, this is not significant. So those are the type of variables that have only one significant factor loadings, but the others, they are still complex variables, and therefore in that case you would say that rotation was not successful. Right. And then there's another way to determine if rotation was successful or not. So they will give you a table, I mean a graph, which is gonna look something like this. So this graph is what we call a the graph for rotation after the graph after rotation, I mean. So now this is the x variable, this is the y variable. We all know the Cartesian plane, and then they'll give you points of those vectors. Let's say they give you points here, they give you point here, and then they give you another point here, they give you a point here. So these are like the points of uh, the vector loadings after rotation. So this is the case. Let's say it's vector 1, vector 2, vector 3, and so on and so on. So now they ask you, was this rotation successful? So now if the points are lying closer to the origin, this is what you call the origin. If the points are lying closer to the origin, or they are lying closer to the upper and the lower axis, this being the upper and this being the lower axis, and then you'll see that rotation was successful in this case. And then if maybe the table looks something like this, and then there are points here, yes, closer to the origin, there's a point closer to the origin, there's a point on the upper and lower axis, as uh, we also as we also see there, and then you find that maybe there are some points here. There are some points here. Then in this case, rotation was not successful. So meaning now there are three conditions to a successful rotation. There are three conditions to a successful rotation. Let me just reduce this a little bit, and yeah, there are three conditions. Number one, it says that points should be closer to the origin. Point number 2, condition number 2, points should be closer to the upper and lower axis. Last one, there should not be complex variables. Yeah, so that is how you determine if rotation was successful. If they gave a table like that, then you're going to look at the complex variable only. And then if they give you this, then you're going to look at whether the points are closer to the upper and lower axis. If there's a point that lies in between, you don't know for that point if you should name it a factor 1 or factor 2. If, let's say, maybe these are the factors on the Cartesian plane. So basically that is how you determine if the points, the rotation was successful. And yeah, that is all they will ask you. That is all you need to know on study unit 2. If maybe there's something that you feel like I missed, you can just ask in the comment section. Otherwise, yeah, I feel like that is all that we needed to know about vector analysis. And I'll see you guys in the next video when we do study unit 3, which is hypothesis testing. All right, thank you so much, guys. Please like, comment, share with your friends and family, and subscribe. Thank you so much.